Hey, awesome pre-calc honors. Hopefully you guys are doing great. If you are listening to this, 3.6, the chain rule, that means we are coming close to the end of the school year, okay? So the chain rule, let's start out with the definition of the chain rule. Chain rule, woo, let's make a chain. Just kidding, okay. This is going to be defined as the derivative with respect to x if we have a composition of f composed with g of x. Okay, so this is the inner component, and this right here, f, is the outer component. If you have a composition of two functions, then the chain rule says, first, you are going to do the derivative of f with respect to g of x, the entire function. Then you are going to multiply the derivative of the inner component with respect to x, okay? So the chain rule is used for the composition of two or more. You can have more than just two. So let's look at this very first example. Find the derivative, which I'm going to need to be very, very neat, okay? Find the derivative with respect to x of y equals sine, which is the outer component. The inner component is 7 minus 5x. Excuse me. So I'm actually going to use u substitution, okay? I'm always going to be using u substitution for the inner component. So let u be the inner component, which is 7 minus 5x. Then I'm of course going to do u prime. U prime would just be the the derivative of 7 is going to be 0, so it's just going to be minus 5. So u prime is minus 5. So what I'm going to do next is I'm going to let this be sine of u. Okay, so this whole thing is now sine of u because this is just u. Well, the derivative of sine u is going to be, so what we're going to do, how about if I spell it out for you? Okay, d of du of sine u is, so the derivative of sine u is cosine u, okay? But we don't know what it is, okay? So what we're going to do now is we're going to multiply by u prime. Okay, let me zoom it all back out. There you go. So the derivative with respect to u of sine of u is cosine u. But because we don't know what u is, so we are now going to multiply by u prime. So this is right here the inner component prime, the derivative of the inner component. So what we're doing is, hey, when I first take the derivative of the outer component with respect to u, which is the entire inner component, then we need to multiply this to the derivative of the inner component. So that's what that is. So from here, we are going to now replace u and u prime. So u is back to 7 minus 5x. Okay? Times u prime is going to be times negative 5. Just because I want to make it pretty, okay, dy with respect to dx now, it's just going to be negative 5 in the front cosine of 7 minus 5x. So this whole thing is now the answer to the derivative of this. Okay? And it's going to make a little bit more sense the more problems we practice. Okay? So now let's do 2. Again, we have an inner component and an outer component. The inner component is this whole piece. Okay? The outer component is just going to be tangent. So let's check this out. So first, I'm going to let u be the inner component, which is 2x minus x to the third. So let u be 2x minus x to the third. Then let's take the derivative of u. So the derivative of u is going to be 2 minus 3x squared. All right? So from here, I'm going to substitute this with u. Okay? So this is going to be tangent of u. Okay? So let's take the derivative. Instead of with respect to x, we are going to take the derivative with respect to u. So dy of du, of tangent of u, is, okay? So this is your inner component, this is your outer component. So according to the definition, it's going to be the first derivative of the outer component. So right now, we can take, hey, let's do the derivative of tangent. Then I need to multiply the derivative of that. Well, the derivative of u is currently just u prime, okay? Well, we should know by now the derivative of tangent is going to be secant square of u. Okay? Well, again, u prime currently, if with respect to u, is still just going to be u prime. Okay? So from here, we can definitely now substitute in the u and the u prime. So secant square of, okay, 2x minus x to the third, because that's my u. 2x minus x to the third. Okay? Then u prime is going to be times this piece. So times 2 minus 3x squared. Okay? Well, just to make it pretty, I'm just going to move this to the very, very front. So my final answer of dy with respect to x is going to be 2 minus 3x squared times secant square of 2x minus x to the third, and thus box it up. Okay. I'm going to give you a couple more seconds to write that down. And as I'm waiting, I'll tell you a toddler joke. Ready? What did one penny say to the other penny? So what did one penny say to the other penny? We make perfect sense. Get it? Like instead of spelling out making perfect sense, like sense in the situation are pennies, right? So another word for penny is cent. So one penny and another penny, they have 2 pennies. So 2 cents. So they make perfect sense. Get it? Sorry, that wasn't as fun. Let's move on to the power chain rule. The power chain rule, it's a little bit more difficult, okay? So again, you have an inner component and the outer component is just the square. So the first thing I'm going to do, this is going to require a lot of steps, okay? So hopefully we have enough space for it. So first thing is let u be over here. U equals the inner component, so that means sine of x all over 1 plus cosine of x. Now I'm naturally going to do the derivative, but if you look at this, the derivative of this is a lot more difficult than that because this has a quotient. So u prime, okay, it's actually, I need to use the quotient rule. So here we go. It says u prime, the derivative of quotient is going to be sine prime times 1 plus cosine of x, take away 1 plus cosine of x prime. So remember, the derivative is u prime times v, take away v prime times u, which is this piece. I shouldn't be using u and v because I'm already using u and v, but just let's do the top and the bottom. All over, okay, the bottom square. All right? So from here, I have to simplify out my u prime. So u prime equals the derivative of sine is going to be thank you very much, cosine. This is going to copy it over. Okay. Then the derivative of this piece, the derivative of 1 is going to be 0. The derivative of cosine is going to be negative sine of x. Then I'm going to multiply this back to this sine of x in the back. And all of this, guys, is still over, I'm invading definitely this piece. All of this is still over 1 plus cosine of x squared. Okay? It's still over that piece. Let's simplify some more. Let's move it here. Okay? Then u prime, this is just u prime. We haven't even done the derivative of y yet. So u prime, let's see from here, can we distribute? This is going to be cosine of x. This is going to give me cosine square of x. A negative and a negative will make it a positive sine square of x. Okay. Then this is going to give me cosine square plus sine square is 1. So guess what? Look at that. That's a beautiful thing. Except that I forgot the denominator. So the denominator is still going to be 1 plus cosine of x squared. 1 plus cosine of x squared. Okay. Then look. There's 1 plus cosine of x on the top and 1 plus cosine of x on the bottom. I can go some more. Oh my gosh. Okay. So this is going to be 1. This is so exciting. Plus cosine of x. Okay. So this is just u prime. So let me remind you. We haven't really done the derivative of y yet. This is just the inner component. Okay. So this is u, which is this, which I'm going to use. Okay. And then this is u prime. So all of that work is just u prime. Now let me use a different color thing here to do the derivative. So this is now turned into u. Would you agree? Okay, so y equals, this is now u squared. Okay, so that means y prime with respect to u is just going to be 2u, okay, 2u, because I'm doing the derivative, times u prime. Because whatever this inner component is, look at the chain rule. Whatever the inner component is, you always have to multiply by its derivative. Okay, so from here, let's go further. I think I'm almost done. Okay, so from here, 2 times u is my inner component, which is sine of x over 1 plus cosine of x, right? Times u prime is this answer to this long process. So u prime is 1 over 1 plus cosine of x. Okay, let's see if you can simplify this. So this is really 2 sine of x all over 1 plus cosine of x, and all of it is squared. So guys, this is the derivative of y in respect to x. So the longer piece was really doing the derivative of the inner component. Okay, so that took a lot more work than once you have this, then the outer component is not as bad. All right, I'm going to give you another minute to copy it down. Okay, let's move on to example 4. Let's find the derivative. Let me zoom in because since I wrote kind of over it, it's quite difficult to see. Okay, so here we go. The problem starts out with y equals cosecant of x plus cotangent of x, and all of that is raised to the power of -1. So again, just like the previous problem, we have the inner component, which the inner component shows a bit more work, which is cosecant of x plus cotangent of x, okay? So cosecant of x plus cotangent of x. So now I need to do u prime, taking the derivative. The derivative of cosecant of x is negative cosecant of x times cotangent of x. Let me ask you this. What is the derivative of cotangent of x? Did you say negative cosecant square of x? Good job. Okay, so now that I have it, I'm going to zoom back out, because what I'm about to do is I'm going to rewrite this in terms of u. Okay, so instead of y equals that, y equals u to the -1. Then let's take the derivative. I'm going to do it right here. Y prime equals, the derivative is just going to bring down your power. Okay, then you have -1u, then you have to subtract 1 from the power, so now I have -2. Then the inner component is u, so you have to multiply this by u prime. Okay, so now let's fill in all of our stuff. So y prime is really -1, or negative. U is this whole shebang up here. Okay, and then I'm just going to have it raised to the power of -2. U prime is this whole thing here as well. Okay, so U prime, so times negative cosecant of x times cotangent of x minus cosecant square of x. Okay, and of course, you would have to see if this is gonna simplify. Okay. Okay, so let's check it out. This has a power of a -2, so what I'm gonna do is I'm gonna put it in the bottom. Oops, you can't see what I'm writing. Okay, so I'm gonna need a lot of space. Okay, so I'm gonna try to write this really small. So from here, this right here, I'm gonna move it to the bottom. So now on the top, I still have a negative. Okay, and this stays on the top because it's power 1. So negative cosecant of x times cotangent of x, negative cosecant of x squared, cosecant of x, square of x, all over. This has a negative power, which doesn't look very pretty, so we are going to move it to the bottom. Okay. And then from here, I can distribute the negative through. So from here, we're going to go positive cosecant of x, cotangent of x, times add cosecant square of x all over cosecant of x plus cotangent of x, and I have twice of that. So notice how we have cosecant of x and cotangent of x on the top and on the bottom. So you might want to see if things can be reduced. Okay, so from here, I'm going to factor out cosecant of x. I'm left with cotangent of x, and there's an extra cosecant of x here all over. Oh, great. Okay, I have cosecant of x plus cotangent of x, but then I have 2 of these. Okay, because I have 2 of those, one of them can cancel one another. So from here, we are going to, here we go. This would cancel with one of those. Okay, so on the top, I currently have cosecant of x over cosecant of x plus cotangent of x. Okay, so right now that becomes that. So one of this is gone. Well, of course you have to see if you can simplify some more. So from here, cosecant is going to be 1 over sine of x. Okay, then I'm going to divide. This is also 1 over sine of x. Okay, divided by, then plus cotangent is cosine over sine. LCD are the same, so this is going to be 1 over sine of x. I'm going to multiply because the LCD are exactly the same. I can put it all together, so that I'm going to flip it right away. Sine of x over 1 plus cosine of x. So those will be gone. Woo! Look at that. My answer comes out to be nice and pretty. 1 plus cosine of x is the derivative of cosecant of x plus cotangent of x all to the power of -1. And yes, you have to go all the way here. Okay, this is simpler than that. So make sure you go all the way here, please. So I'm going to give you another minute to copy it down. Okay, you know, I'm thinking about doing the next example, but we're just going to hold off, okay? All right, this is the end of the video. Have a wonderful day. Bye-bye.
Example 5 and 6 in your notes packet. So repeated use of the chain rule. So I'm going to start with what let u be, okay? Since I have an inner component, this is my inner component right here. Let u be that inner component. 1 plus cosine of 2x. Looks like if you can see this, I'm about to take the derivative of this, okay? So u prime is, and do this very cautiously. The derivative of 1 is 0 because 1 is a constant. The derivative of cosine is negative sine, okay? So technically, this is the derivative of cosine of 2x, which if you really wanted to, you can let 2x be another variable. Let's just say w or v, okay? And then do another chain rule in that way. But I'm going to do this. So derivative of cosine of 2x is negative sine of 2x times, based on your chain rule, times the derivative of the inner component. So u prime is negative sine of 2x times the derivative of 2x is just simply now 2. Then let's put the 2 in the front. That u is extra long, isn't it? Let's put u in the front, not u, 2 in the front. So this is really negative 2 times sine of 2x. So that is the derivative of 1 plus cosine of 2x. So now what I need to do is not move the screen. What I need to do is rewrite this equation. As you can see, y equals, the inner component is now u and then square. Okay, so it's going to be u, so y prime is going to be 2 times u prime. Now I just have to plug everything back in and make sure I FOIL or multiply everything out nicely. Well, u is simply 1 plus cosine of 2x. That came from this right here, okay, and that's in the component. Then u prime, that piece right here, u prime is what we had to do on our own. So times u prime, which is now negative 2 times sine of 2x, okay? Then let's try to multiply this out very slowly. You can technically multiply this and this first, so let's do that, okay? So 2 times that is now negative 4 sine of 2x, and then that is now 1 plus cosine of 2x, bring that down. So what I did was I multiply this and that first. Okay. So now let's slowly multiply this out. Here we go. Negative 4 sine of 2x times 1 is negative 4 sine of 2x. No big deal. Negative 4 times that right there is going to be minus 4 sine 2x cosine of 2x. Okay. So negative 4 sine 2x and cosine 2x is just, we can't do anything about it right now. So let's leave that as is. Now, I hope you remember the identity. This is from memory, okay, of double angle of sine and cosine. So let's do sine first, because this is what I see. Sine of 2 theta, remember back in the days, is going to be 2 cosine of theta times sine of theta. Well, what if you have sine of 4 theta? Sine of 4 theta is just simply 2 times that, right? Which is really sine of 4 theta. So what if you have sine of 4 theta? Then what that is really 2 cosine instead of just a theta. Now it's 2 theta. Okay, so 2 theta cosine of, oops, I already had cosine. So sine of 2 theta. Cosine of 2 theta and sine of 2 theta. So that is sine of 4 theta. Now, why do I need to know this? Well, I kind of see a couple of things in my answer here, right? I have this guy right here. You see this guy right here? I can rewrite that as, I'm going to copy this down, negative 4 sine of 2x, leave that as is. I'm going to rewrite 4 as a 2 times 2 sine of 2x cosine of 2x. Okay, this right here is a double angle identity of sine of 4x. So now I will definitely need to put it back in negative 2 times sine of 4x. Okay. So as you can see, this is a lot simpler to look at. So negative 4 sine of 2x minus 2 sine of 4x. I'm just trying to get rid of that dot right there. Now I can combine these. So guess what? This is as far as we will go. Okay. So final answer. So the derivative of 1 plus cosine 2x, all of that quantity square, is negative 4 sine of 2x minus 2 times sine of 4x. Now, let's do the last example in the chain rule section. Okay. Again, you have y equals square root of tangent 5x. I'm going to let the inner component be u. Okay, so u equals tangent of 5x. Then let's do u prime. U prime is tangent, the derivative of tangent is secant square of 5x, and I need to multiply based on the chain rule the derivative of the inner component, okay, which is 5x. Now, slowly copy this down, secant square of 5x. I don't need to do anything with that, but the derivative of 5x is just now 5. But I'm going to write that in the front so I'm not confused. That with 5x times 5, and that's 25x. That will be completely different from secant square of 5x. So the derivative of tangent 5x is 5 times secant square of 5x. So that's my inner component. So what do you need to do here? Write y equals square root of u. Okay. Now, if you wish, you can totally write square root of power of half. Okay. Move that over. So y prime, based on my power rule, is 1/2 times u. Subtract 1 from a half is now negative 1/2 times u prime. Then from here, slowly work this out. And no, you have multiple ways of doing derivative. You don't have to do it this way. So now I have positive 1/2. U is this guy. Okay, so plug that in. Is now tangent of 5x to the power of negative half. U prime is u prime is now this guy, so plug that guy in. Okay, so u prime is 5 times secant square of 5x. Now let's try to make it as pretty as we can. Not all the time that you're going to be able to make it really pretty, but we will definitely try our best. Okay, tangent 5x to the negative half power, class, is the same as 1 over square root of tangent 5x. Okay, and again, that is true. Well, if that's too fast for you, how about this? I'll write it in this way first. Tangent 5x to the positive power of half, and bring it to the bottom. Because anytime you have a negative exponent, you can move it to the bottom to make it positive. Then I'm going to make this into a fraction as well. What I'm trying to do is I'm going to write everything out in multiple steps so you can see how we go from one to the next. So y prime is, now I can write it in radical, so here we go, square root of tangent of 5x, okay, times 5, so, well, 5 secant square of 5x times 1, that's just now 5 on the top, so I'm just going to write 5 on the top. 5 secant square of 5x. Now, is there anything you can do from here? Not much, really, because the tangent of 5x is under the radical, so you can't really simplify. And so, therefore, this is as far as you can go. So, this is the final answer of, so that's the derivative of square root tangent of 5x. And this concludes our video for the day.